Welcome, everybody. This is the Rotary eClub of Silicon Valley, and every week we bring you the stories of people who are making life better for others, doing things that inspire people to see new possibilities within themselves, to imagine how they might improve life for others, to advance things in such a way that they can use technology to serve the business of service, all kinds of different possibilities. We're part of Rotary International. Rotary International is 1.2 something or other million people who are dedicated to service above self, that joy and meaning that come from serving others. We're spread across 36,000 clubs around the world, and our club, the Rotary eClub of Silicon Valley, is one of them. Ours happens to be both online and asynchronous, which adds a level of flexibility for our members, also meaning that wherever they are in the world, they are able to participate in how we do things. If you're curious about curious to learn more about our club, then feel free to go to siliconvalleyrotary.com or just rotary.cool. Today, we have speaking with us a student from Westmont High School, and she is part of the team 3482 Arrowbotics. So it's a high school robotics team. We're excited about the kinds of things that she has to tell us, as education is one of the principal interests of our club, and we also are very happy to have been a supporter of their club in the last year through our mini grant program. So with that, I invite anyone watching this recording to get more info by pausing and going to the webpage where you found this recording, either the podcast or the video, and you can learn more that way, or you can just let Mia tell us about it. Mia, we are very happy to have you speaking to us. I hand the mic over to you.
Hello, thank you. I'm Mia Hanuska. I'm Vice President for Team 3482 Arrowbotics. We're based out of Westmont High School. So who are we? We are a fully student-led, taught and run team, robotics team. Our rookie year was 2011, so we're 13 years old, and we're an after-school club. We work outside of a classroom that a teacher lends to us. We have a small little room that we're allowed to keep our machines in. So although we may be a pretty large team, we have a pretty small workspace. We compete in 2 to 3 competitions annually. One of them is in the fall, and that's unofficial. It's to gain support from new members. And then we have 2 official competitions in the spring. Last season, in one of our official competitions, we placed 19th out of 60 teams, which was one of our best performing seasons. It may not sound super great, but it was one of the hardest competitions held that year. And to us, it's a really great accomplishment. What do we do? Of course, we're a robotics club, but we are also a part of FIRST, which stands for Inspiration and Recognition of Science and Technology. FIRST has multiple groups of robotics competitions, and we're part of the FRC, which is the program that is for high schoolers. FRC puts out a new prompt, a new game every January, and then we design, build, and test a robot in the next 8 to 10 weeks after that. Once we have a robot, we compete against high schoolers from across the globe. And when I say across the globe, I mean that teams from Taiwan, Turkey, Israel, they all fly to the Bay Area to compete against teams like us, which is really exciting for our students because it means that they get to experience and talk to members from teams of different cultures, and also they get to see how they solve a problem that we might not have because we're in different countries. How do we work? We're a pretty large team. This year we have about 40 members, so we're split up into 6 divisions. Our first division is CAD. CAD is in charge of designing the robot and planning it. So CAD uses Onshape, which is a web browser, like CAD software, and they figure out all of our problems before we actually build the robot, because it's very expensive and very time consuming to make fundamental mistakes in your design when you're building out of metal. So CAD is able to eliminate this step and makes it so that we can easily create a design and share it across the team. Mechanical then takes the CAD and they physically build the robot. So this means that they're actually cutting all of the parts, they're screwing it together, they're attaching the pulleys and the belts. This makes it so that we can have a robot to actually compete with. Once mechanical is done, they give it to electrical, who give power to all of the motors, the encoders, the cameras. They are in charge of soldering everything, making sure that the battery can connect and give power to all of the parts. They're a very important part of the team. Electrical then takes the robot and gives it to software. Software uses Java to code all of the software that we need to make everything move. Electrical makes everything have power. Software makes everything move. Then we also have two divisions that are non-engineering. And so first is PR and media. They're in charge of our social media. They take photos. They make our Instagram reels. And they're in charge of making sure that we have a good public image. Business fills out grants, allows us to get funding, and allows us to continue working as a team. One of our fundamental ideologies is that students are teaching students. As I said, we are a student-led team. So this means that students are the ones that are teaching the new members and the ones that are actually building the robot. So student members will come in with no previous experience. I mean, robotics is kind of niche, so a lot of people don't know CAD or don't know mechanical before they join. So our own students that have been in the program for years then teach these new students how the skills they need in order to improve and in order to build an actual robot. These are photos from our workshops that we hold in the fall, so that way they can be prepared with the skills they need in the spring. Through Arrowbotics, our members learn communication and teamwork. It's important to be able to tell people from other divisions, I need this done, and this is how I need it done. So through robotics, they'll learn how to communicate what they need and how to work together with divisions. CAD and mechanical work really close together, and electrical and software work really close together. So it's important to be able to talk to them and know what each other needs. They also learn how to think like an engineer. This is problem solving. This is when we have 30 minutes after one of our matches at competition and something broke, we need to figure out how to fix it. This is learning what works and what isn't going to work and being able to determine it in a quick thinking. They'll also learn time management. I mean, our robot has to be done before competition, right? So they need to be able to meet the expectation of having a robot and meeting all of the deadlines so that we can have practice with it and have a completed robot. Of course, they'll also learn engineering specific skills. Each division has their own skills: CAD, machinery, Java, electrical. These are all skills that are widely applicable to the workforce. Our skills in Onshape that we teach are very applicable to the industry standard CAD software, and Java is a language that a lot of companies use. We also offer leadership opportunities for students. We have 9 executive board opportunities, and that's head of CAD, mechanical, 2 heads of engineering, head of electrical, 2 heads of software, head of business, and then of course, president and vice president. And these are students who can apply after their first year. So as a lot of these people can be sophomores and still be able to be in a leadership opportunity, a leadership position. We also have 12 specialty positions. These are less time intensive and more specialization. So for example, we have 2 people that are in charge of prototyping. And whenever we have problems, we can just go to them and we can say, why isn't the prototyping working? Or how's the prototyping coming along? We can ask them any questions about their position and they should be able to answer all of them. Our team also offers hands-on experience. As I said, we're a student-led team and we believe in students working on the robot. So when we have a problem, you're not going to see mentors coming in and immediately solving it for us. We offer the experience of students learning how to solve it. And so as a freshman, I had experience working on the robot. I mean, I built bumpers. My CAD design was used for the final. So even as freshmen, they are given the opportunity to work on a robot, which a lot of teams don't offer because a lot of teams are their freshmen are like the coffee getters, the broom, the sweepers. But here we try to include everybody as much as we possibly can. This is an overview of our year. So in the fall, students join with no experience. They don't know anything about robotics. And then in October, actually in a few weeks, we have an off-season competition. And this allows students to participate and experience in their first competition, which is so exciting because competitions are arguably one of the best parts of robotics. It's so exciting to see your design come to life and see all of the other teams' designs and what they did differently. In January, our season officially begins. So we build a robot, we design it, we perfect all of the skills that we learned over the fall, and we put our heart and soul into this machine. Then we compete in our 2 competitions against 40 to 60 other teams, depending on the competition. And then we repeat this every single year. I know my siblings were in robotics. A lot of the other members, their siblings were in robotics. And so it's great to be able to teach multiple siblings and multiple generations of students. Funding. So robotics is expensive. We rely on grants, sponsorships, and donations. All of our funding goes directly to students and working on the robot. So our budget is around $35,000 every year, and that has to pay for competitions, registration, which is just in order to be part of FIRST, you have to pay a lot. And then, of course, building the actual robot. Parts are really expensive. And then you also have to have the machines in order to design all of your parts. So of course, there's off-the-shelf things, but a lot of stuff is made in-house with a CNC or with a mill, and those machines can add up. We are extremely grateful for the mini grant that we received from Rotary eClub of Silicon Valley. It's allowed us to purchase so many new parts for our robot, including the motors in the upper right-hand corner. That photo, those motors are really nice. They're really new. They're also really expensive. And so we're so appreciative that we were able to afford it thanks to you guys. Thank you.
Wonderful. Thank you, Mia. All right. So I'm going to introduce the people we have got in the group. And so, Mia, I'll have you stop sharing there. So from our club, we have 4 members. So we have in Houston, Roy Olson. In Walnut Creek, California, we have Shag Shagrin. In the Sacramento area, our president, Mike Kane. My name is Rushton Hurley. I'm in San Jose. Joining us as part of this is one of the teachers who helps the robotics team from Westmont High School, Eric Shu. We're good to have you, sir. And so, Mia, let's jump into some of these things. First of all, in talking about the launch of the competition, you said, okay, it begins in January. I've seen one of these competitions kick into gear, and the launch is a big deal. Could you tell us more about that part of the experience?
Yeah, the launch, or we call it in the robotics community, kickoff. It's super exciting because you spend all of fall like making these skills, and at the end of the year, or the end of the on season, they give a teaser on what the theme is going to be. And so there's a lot of theories that are floating around. This year, it's named Reefscape, and so a lot of people are saying, "Oh, it's a water game," and that's been an ongoing joke in the community for a while, because obviously robots and water don't mix well. And so kickoff, it's super exciting because you get to see what all of the theories, if any of them are true, you get to see if you get like the actual pieces that you're going to be building with, or you're going to be aiming to score, I suppose, get points with. And so it's like really nerve-wracking because there's all of this buildup, and then you're quickly like, okay, well, this is similar to this year's game of, this, where it has the similar game piece, or it has a similar objective to this year. And it's so exciting because you get to finally put all of the skills that you've learned, you get to start putting it to use.
So how much of the preparation involves really talking talking new members of the team through challenges that the team has faced before, as a way of trying to build a sense of problem-solving process.
Yeah, we do that a lot in CAD because they're in charge of the actual like design. So we have them CAD robots based off, or we have them CAD, yeah, robots based off of previous years. And that's just a great way to learn how all of the systems work, how like a shaft is connected to a pulley, how it's connected to the belt, how it's connected to the motor. And then also we'll do some exercises where they get a prompt, an old prompt, and then they have to come up with their own design for it and do a rough sketch. A lot of divisions, I mean, I came from CAD, so I'm not really sure if electrical does things like that, but I know code definitely does. They'll look at past years as code that other teams will release, and then they can use that as a basis for what they might need to know for the year upcoming.
Well, it sounds like a lot of research gets to be part of it as well. And so when we think about being prepared for these different challenges, you mentioned using a CNC device. Is there a lot of fabricating your own parts through different kinds of 3D printing techniques or something like that?
Yeah, we try to have almost all of our parts fabricated in-house. We have a sponsor, Fabrics, that does plasma cutting, and so the things that we aren't allowed to do, we can't do because our CNC just doesn't have the ability. We outsource to them, but it's our design that they're just cutting out. And a lot of our parts are 3D printed. We have 3D printed pulleys because a lot of also the thing is a lot of parts get back ordered because robotics is kind of small. It's a small community. I mean, like there's a lot of teams, but the actual companies don't make a lot of product. And so when we don't have access to a lot of things that we need, we are forced to make it ourselves. We 3D print pulleys, mounts, spacers, because those can get really expensive. Pretty much everything. And then our CNC, we have a certain section of like CAD-ish mechanical kids, and they take all of our designs and CNC it for us so that we can use it on our robot.
Nice. Now, clearly, a lot of this is just the kind of experience you have with other students. All of this is theory, and then bam, you're in a competition, and you're suddenly seeing how intense it can be. Can you describe like a moment or two from this kind of thing before, where you're able to really kind of convey some of that experience to the people who are catching this as a recording?
Yeah, it's exhilarating. I mean, so I can speak from my experience. I was a driver of the robot. So we'll have two people who actually control the robot during matches. And last year, actually around this time, I was one of the drivers. And it's kind of nerve-wracking because you know that the entire like team is kind of hoping that you're gonna do super well, right? There's all of the sounds that are coming because each match has there's like sound effects so you can tell which part of it you're in. And then you're there and you're driving it and you see it going around and you're like, whoa, I just scored that. Like, let's go. And even in the stand, you're watching and you're cheering your team on. There's this really great like team spirit, you know? And so it's absolutely amazing because you're seeing your team do so well against all of these other teams who have also spent the exact same amount of time as you. And it's like it's rewarding and it's exciting. And then you get to talk after the match and you say, "Oh my God, you did so great." And it's it's like the best feeling ever.
Well, I'm thinking you're tapping into that thing that inspired President Mike to say I'm gonna propose a mini grant along these lines. He has a great comment and question in the chat that I'll read. Having attended the fall event in the past, I was blown away by the support and spirit of students, parents, and guests. The enthusiasm and competitive energy was equal to Friday night football. Tell us how you interact with your peers at school to make that school spirit come through.
Yeah, I mean, at school, we have, I don't know, like our school spirit, we go to a lot of the school events with our robot. So that's one way we have a lot of school spirit because we'll go to club fair, we have like a parent night, we'll go to back to school night so that they can see our robot. And at competitions, I mean, you're with your little, I don't know if like click, but you're with your team in the stands and all of you guys are cheering for the same robot and there's chants going back and forth. And so at school, being able to foster that is building the community. We'll have game nights. I mean, we have a team Discord where people can interact and get really close. And we do a lot of like events together that are sort of unofficial. Like as a team, we will unofficially take a photo at a school dance or we'll um I don't know, go and get a drink together. And so that just builds the community of our team. And I think it really strengthens us because it makes us we're able to work better together. And it's like exciting. You know, you have that, you're all cheering and you're all close. It's like another family.
I can imagine Instagram pics that have the robotics team on a boba tea run. That makes plenty of sense to me. In terms of connecting with others, one of the things you talked about with First is that it's international. So you're getting to meet people from all over, and tell us a little bit about the experience of talking with people from different countries who come here or to the other places where they have these competitions, and what you learned and the people you met.
Yeah, it's an interesting um way of I don't know, it's difficult to communicate sometimes because they're from a different country. Obviously, they speak another language. And so trying to get over the communication, I mean, it's not like robotics terms are super widely used. And so even if you know part of a language, it's still difficult to communicate like, hey, where's your Kraken motor located? How many wheels do you have? Those aren't terms that, you know, normally come up. And so just trying to get over the language barrier is something that is really interesting and it's really in I don't know, I feel encouraged by it because I'm like, you know, pointing and then you got the Google Translate open and it helps you learn a lot about how communication needs is so important and how it needs to work, right? Like you can't it's hard to ask questions when you can't speak the language. But I know our current robot design, it's based off of an Israeli bot who won the world championships. Personally, I've never met any of the people in the team. I mean, when we're going around in at competitions, typically you don't get super close with a lot of the other teams. It's quick like, wow, you did really well in your last match. What changed from your previous ones? Or tell me about your robot. And then they just tell you everything. And then you write it down and you kind of leave. But then it's also when you're planning a match, you're with two other robots, two other teams. And so then seeing how they are trying to communicate with them and seeing like they need to have their path this way and then getting creative with how you're telling them, that's also a really important and interesting way to connect with them.
Another question that came up through the chat has to do with the divisions, the groups that are part of the overall team. And I think for a lot of people, when they hear about robotics, they would be surprised to learn that there's a PR media group and a business group. Can you tell us a little bit more about their roles and how people begin to discover a love of robotics through kind of very different avenues?
Yeah, our PR and media team and business teams are very small because, as you said, a lot of people, it's not the first thing they think of. When you think of robotics, you think building a robot. People don't know the nitty-gritty details of it, the work that has to be done behind the scenes in order to actually be able to build the robot. And so our PR teams, it's a great way for students who might not be engineeringly inclined to kind of get that experience. They get at competitions at least, they get to go through a special spot and take photos in the special seats in front of the field, which is super exciting because you get to see the robots up close. And so I know also through like business, it's writing a lot of grants. In order to write grants, you have to know about the team. So they need to have the knowledge of so many things, all of the divisions. They need to know what we do in each division. They need to know how we approach problems. And so it's a great way for them to kind of learn about robotics, but not actually have to, you know, a lot of people say, I'm not smart enough for robotics, but there's always a spot for people if it's, drawing the posters that we put up, if it's designing the Instagram stories, if it's writing and how saying how great we are of a team, you know, it's it's a way that people can dabble in it without needing to, commit to like an engineering degree.
Fair enough. Sounds like drawing upon a diverse set of talents is a good way that a service club might work as well. Let's do like one more question, then we'll wind down the recording. We'll keep asking you questions because we get to do that in the eClub and we connect with these fascinating speakers and get to learn all sorts of cool things. And that comes down to this. Robotics is a field in which you are learning tons, right? I mean, there's just so much learning that's a part of it. You're in high school, so you're kind of a professional learner in many ways. How would you explain to someone else the difference in terms of the learning that you do in robotics, as opposed to the learning you do in most of your classes?
Oh, it's very different. The biggest difference I would say is the hands-on aspect. In class, in math class, in physics, you're dealing with these conceptual numbers, right? You're saying, suppose there's the friction and the gravity, but with robotics, and I know this is especially for software who has to figure out all of the math so that the robot ends up where it needs to go. It's it's saying, well, this friction is caused by this, and I can tell and I can experience that by, moving this part of the robot. And so it's definitely more of a hands-on experience. You are physically measuring how big something needs to be. You're physically seeing the size of a motor. You're experiencing the learning that you may see in your classes, but in a way that's a lot, I wouldn't call it better, but it's easier at least for me to learn, right? Because it's something tangible. And so it's exciting because you get to see all of your calculations and all of your learning, all of the experience you gain. You get to see it kind of come to life in the final design, which is something that a lot of normal classes you don't really see.
Well, I love that it's experiential. I think service being experiential is the kind of thing that excites people as well. So we'll use that as a metaphor. I'm going to wind down the recording and then I'll hand it back to Mia for the final word. But for all of you who have taken your time to watch this or listen to the podcast, we have multiple podcast series that we hope will inspire you while you're exercising or commuting to work or whatever it might be. And we hope that you will spend a little time visiting our club at rotary.cool and learn about the different ways that we connect with people around the world who might be really, really busy but have a heart for service and love the idea of connecting with like-minded people who are very into the idea of we can do all sorts of cool and creative things to make the world a better place. As we always like to do, we hand it back to our speaker for the final word. So, Mia, what would you like people to have clearly in mind as they finish the podcast or video?
Well, Aerobotics, we're student-led, and we are just a bunch of students who really like robotics. We like engineering, and we're super glad that through your help and so many others, we are able to follow our dreams. We're able to create these robots, and I'm super excited for the upcoming season, and I think we're gonna make a great robot. So I'm looking forward to what's to come.
And we look forward to seeing you again next week. Thank you for joining us.